All right.
Big shoes are expensive.
14.3, verify trig identities.
Okay, stop. Oh, it's so gross.
All right.
It was you? Literally you.
Someone you can ask about your feet. Like, what type of toes do you have?
I said no more.
Now we're on recording and you're asking
I
about
literally said no more.
What type?
Sine of theta is equal to negative 7 over 10. Pi is less than theta is less than 3 pi over 2. The instructions say to find the other 5 trig functions of theta.
Whoa, wait a minute. What happened in here?
I don't know.
What? What is
I
this?
wrote down the
Didn't we
formulas and
this was like
understood them.
13.1.
It's not though.
Okay, so I don't know how to do it.
Okay, let's do
We have
this.
to like do cosecant or something.
So we are going to. Okay, what quadrant is this?
3.
Oh.
Yeah, I said,
Okay, quadrant 3. So I have sine. I'm gonna find cosine. I'm going to do that by using sine squared plus cosine squared equal to 1.
oh. Wait, yeah.
I'm going to plug in negative 7 over 10 and square it. Plus cosine squared of theta is equal to 1. Cosine squared of theta is equal to 1 minus 7 over 10 squared. I can rewrite this as 1 minus 49 over 100. I could technically rewrite this one as 100 over 100. So cosine squared of theta is equal to 51 over 100.
Oh, it's not negative. That's only one of them.
I'm
You gotta find
already-
the
We're
other
not done
four.
yet.
I'm already using too much space then.
Oh, this problem took up an entire page for me.
What the?
Bro.
This is just the one.
This is just cosine.
Can homework be like one problem?
Oh, she said it goes. We finished it this one. You said this is 2 days, right? This is
Oh, good, good. Okay, thank goodness. I feel like
Oh, wait, how do you figure out which one you use?
this is a weekday.
Well, I'm going to show you this, and then I'm going to show you an easier way to do this problem. But I'm showing you how to use your identities at the
How do
moment.
you figure out which one to use?
For like the.
The
What do you
one
mean?
with the thing you have? Or like,
What do you mean?
Like
Wait.
which identity?
Which,
Oh,
like,
are we
there's so
only
many
are we
things.
only dealing with Pythagorean identities right now?
Yes, at the moment.
Oh.
It's just like trying to solve for other pieces based on what you have. Yes, there is an easier way to do this, and I will show you that in a minute. I'm just trying to show you how to like manipulate your identities at the moment.
Okay.
I'm probably just going to do cosine this way and then switch to the easier method.
Okay.
But just trying to show you how to quickly solve them. So take the square root. So cosine of theta is equal to plus or minus the square root of 51 over 10.
Oh, we're back to this.
But now I have the issue of, do I need the positive one or the negative one? Based on where I am.
Wait, that's a 51 over 100.
Yeah.
Square root. of
But I'm
51.
taking the square root of the whole thing, and the square root of 100 is 10.
Oh. Sorry. I was confused.
Me too.
Not giving you a cookie point that easy.
I know, but I was just really confused. It was like, what? Okay. Wait, so what are we doing?
I need to know if I need the positive or the negative one based on where It is.
You need the negative.
Negative.
Okay, I need the negative one, so I technically need negative root 51 over 10. And then we can set up the, all this fun stuff.
All the good stuff.
So sine was negative 7 over 10, meaning cosecant is negative 10 over 7. Cosine is negative root 51 over 10, meaning secant is negative 10 root 51. Oops, I can't. Negative 10 root 51 over 51. So then tangent, I will go ahead and just do this on the long way, and then I'll show you the easier way to do them on the next one. So then tangent, in regards to I have sine and cosine, what is tangent?
Sine over cosine?
Sine over cosine. So tangent is equal to sine over cosine. So that would be negative 7 over 10 over negative root 51 over 10. Divide by a fraction is same as multiplying by the reciprocal. So negative 7 over 10 times 10 over negative negative square root of 51. 10s cancel, leaving you with negative 7 over 50, or the negatives are going to cancel. Get my words in order. Negatives are going to cancel. 10s cancel, leaving you with 7 over the square root of 51, or 7 root 51 over 51. Okay, cotangent, all you have to do is flip it. You could also do cosine over sine and follow the same procedure, but you can just flip it over. So this was 7 over the square root of 51, so it's just the square root of 51 over 7.
Did you do the longer way
That
on
was
the
the
paper
longer
design?
way?
Or was that the longer way?
That is the longer way.
Okay.
But what I'm saying, you can go back to kind of what we did in chapter 13 and do these problems too. I'm okay with you doing it that way, but I want you to, like, the next one I'm going to do, I am going to do that way. I just want you to see,
That way?
huh?
Is it easier to do that way?
Yeah, and it takes up a lot less space. But
This only took me half a page. Fine.
Why didn't you have like the third?
I mean, on my paper, I technically went and did cosecant as 1 over sine, 1 over the negative 7 over 10, and blah, 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 to show the long way
Oh,
instead of just flipping it. But it doesn't, you don't need to see that.
Okay.
Just know that that's what's happening.
On the quiz, we'll be able to like just flip it and stuff.
On the quiz, you can use the shorter method that I'm going to do on the next one, too. Like, I don't care. I just wanted you to see the identities kind of in use and how we can use them. If you struggle with putting things in the right spot, like the right quadrant, it might be beneficial to do the longer method, potentially. But, all right, let's do number 8. So 8 is the secant of theta is equal to negative 9 over 4, and it's pi over 2 less than theta less than pi. So where does this one occur then?
Oh, wait. Quadrant 2.
Okay, quadrant 2. Okay, now some things to think about. I want to draw this. I know it has to be in quadrant 2. So I know that it's got to fall somewhere over here. Okay. Now, secant goes with what?
Cosine.
Okay, it goes with cosine. So in this case, I have hypotenuse over adjacent, right? You agree with that? Cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. But the biggest thing is I've got to figure out which number is negative.
Oh.
Which number would be negative with the hypotenuse and the adjacent in quadrant 2? kind of a trick question.
No.
Can the hypotenuse ever be negative?
No.
No. So, hypotenuse can't be negative, so I know that that has to be 9. Adjacent has to be -4. And then I just need to find the other side. And then I can just proceed like normal. Okay, if I were to have tangent, okay, then it's a little bit more complicated because it's not just simply saying, oh, well, the hypotenuse can't be negative, so it's not because you don't have the hypotenuse. You have your opposite and your adjacent. So you have to look and say, okay, well, in this case, my y value has to be positive, my x value has to be negative. So if it gave us the tangent instead of secant, it would be a little bit more difficult to figure it out, but it's really just looking at the picture. Does that make sense? Okay, because I think we had only done these with sine, cosine, and, well, we might have done them with tangent when we did them before, but I don't remember. All right, so how do I find this other side?
Haggard.
Which is what? Like, you can fill in the numbers.
A squared plus, minus, okay.
Okay, maybe I should just write it out. A squared plus b squared equals c squared.
Oh, that, yeah.
Okay, I'm trying to find one of the sides. It doesn't matter which one. So a is equal to the square root of c squared minus b squared.
Oh, what?
And then you can just plug in numbers.
So,
Square root of 81 minus 16, which is the square root of what? That's-
65. GC was it.
65.
All right. So square root of 65. And then now, given that information, I can solve all of my trig functions. All right, so we were given secant, meaning easily we can find cosine. It's just -4/9. What would sine be?
Would be square root of 65/9.
Cosecant, or well, I'm just going with the ones that are paired.
65/65.
965/65. How about tangent?
Square root of 65 negative square root of 65.
Yeah, that's fine. It
What's
just, the
that?
negative can go wherever.
Yeah.
And cotangent,
-4 square root of 65/65.
beautiful.
There's nothing beautiful about it.
The last class tried to tell me that the answer for sine is the same thing for tangent, and I'm sitting there after I wrote it down, and I was like, are y'all sure?
Oh no.
And they were like, wait, what? And I was like, tangent cannot be the same thing as sine when the numbers aren't the same. And they were like, what? I was like, oh my goodness. And then they figured it out.
How did you say for tangent that we figured out which one was the negative one?
So with tangent, if you had, so let's say that you were given -√65/4, okay? You know that tangent is opposite over adjacent. So you have to look at what quadrant you're in. So you have to go, okay, I'm in quadrant 2, so what does that mean about my x and y values in quadrant 2? Quadrant 2, x is negative, y is positive. So I have to think about, okay, my opposite is my y value, my adjacent is my x value.
Oh, so the x value would be negative.
So the x value has to be negative
Okay.
because it's,
Yeah. Because
Yeah.
what quadrant?
yes.
Okay.
Let's see. Let's do some simplifying problems. That'll actually use these identities. And the thing about these is they're similar but different. Okay? Which I know you're like, what? that means that they all follow similar procedures, but they're all different. Like, you have to look at your identities, get to know your identities. They're going to be your friend. They're going to be your best friend for a while. Huh? Okay. They're going to have to be your best friend for a while because of solving these problems and what we have to do them. So, number 10. Sine of x, cotangent of x. And the goal is to simplify as far down as possible. Okay? So, the thought process that I have is what can be rewritten as something else?
Sine and
Cotangent.
cotangent. Sine can be like cosecant. right?
Cotangent can be
Like,
rewritten as
tan-
1 over the tangent of a.
Okay, so that's one way I can rewrite cotangent as 1 over the tangent. But I want to try to get something that might let me cancel something with sine. So I want cotangent in terms of sine and cosine, if possible.
Cotangent. Wait, sine.
Okay, one of your identities should say cotangent is equal to something in regards to sine and cosine.
Cotangent
Oh,
is equal to cosine over sine.
So we can rewrite this as cosine of x over the sine of x.
Is this where we have to memorize like all these?
Yeah.
So then we can
At some point, though, like, you're going to realize that there's only a couple that you really need to sit down and memorize because at a point, cotangent is going to come natural to you. Tangent is going to come natural to you of, like, what it's equal to. The Pythagorean identities, did I show you in the video how to get from sine squared plus cosine squared equals 1 to the other two options?
Yes.
Okay.
Yes.
Because I'll say if not, I need to do that. Because if you know sine squared plus cosine squared equals 1, and then you know anything about your identities, you can find the other one. So it's like you don't necessarily have to know everything. If you know a little bit about each of them, you can figure out the rest of them, kind of.
So can you cancel out the sine?
Yep, so sines go away, and that just leaves you with cosine of x.
That's your answer.
Yep.
That's hard.
Let's see. 12 cosecant of theta sine of theta plus cotangent squared of theta.
Oh.
I can definitely.
Okay, so again, thought process. Okay, I'm trying to impart all of my wisdom on you. Okay, look and see if there's anything that can be rewritten in terms of something that you can cancel.
Oh,
Okay, so look at the cosecant times sine first. Is there something that I can cancel that way?
you can cancel sine.
Okay, cosecant.
Equals 1 over sine.
Yep, cosecant is 1 over sine. So, that means those two things can cancel.
So it's just
Okay, so that leaves you with then 1 plus the cotangent squared of theta. But, is that as simple as I can go?
No, because 1 plus cotangent squared of theta equals cosecant squared of theta.
Okay, this is equal to cosecant squared of theta.
I love when things go together.
Okay, now what I am going to warn you, caution you, whatever, sometimes it's not going to be one that's blatantly in front of you. Okay, this one is 1 plus cotangent squared equals cosecant squared. What if you had cosecant squared minus 1? It's equal to cotangent squared. Okay, so sometimes you may have to manipulate a little bit, but we want things as simple as possible. Okay, it's important that you show steps on these because let's say hypothetically you stopped right here. Okay, you're not going to lose all the points because you got from here to here to here. Okay, but because you didn't go all the way, you are going to lose some points. Okay, you're just not going to lose. You're just not going to lose as many. That was scary.
They usually are.
All right, then 14. 1 plus tangent squared of pi over 2 minus x.
easy.
So look for something that can like possibly cancel out.
Yes, that would be what I would do first, but I don't have like sine
Right.
times
So-
cosecant or tangent times cotangent or something like
1
that.
plus Tangent squared of theta equals secant squared of theta. So can you switch that or would you not?
Well, the problem is because of this, how this is written.
Okay.
So if you look, you should have some identities in there that actually look something like this,
Yeah.
minus the
Yeah.
squared part.
Is it
Well,
cotangent theta?
tangent times pi over 2 minus theta equals cotangent. But
What's
that's
the
an
theta?
adder, so
Doesn't
Well, x and theta are the same thing. Don't let that confuse you. They're both variables.
Oh.
Okay, it doesn't matter. You can change them all to be x, all to be theta. I don't care. Just don't mix them in a problem.
Wow.
So you said the tangent of pi over 2 minus theta x whatever
equals cotangent.
equals cotangent. This was squared, so it's going to be 1 plus cotangent squared of, I'm going to keep it, since that was an x, I'm going to keep it as x. So then 1 plus cotangent squared is equal to
Cosecant squared.
cosecant squared of x.
Okay.
So do you kind of see what I mean by like they're all similar but they're all different too, like
Yeah.
Yeah, I hate it.
It's all connected.
This is probably the hardest stuff we've done so far with trig,
It's
so
really not too hard though. It's just like memorizing a formula.
it's giving you a false sense of security before we get to double and half angle formulas, because then you're gonna
This is
really
security.
hate it.
Words.
This is security.
What?
I don't like those words that just came out of your mouth.
I don't like that this is my security. I don't feel very safe.
I said, don't let this give you a false sense of security.
It is not.
All right, 16.
16.
Cosine of pi over 2 minus theta over cosecant of theta, oops, plus
What?
cosine
Oh.
squared of theta.
What are you doing?
You're doing something.
I'm gonna look through the teacher hand, like the
Yeah,
whole
see if this is
handbook, and see
legal.
if this is legal here. Okay, so
You wanted the advanced credit, so I took this class.
the cosine of the whatever that is.
The cosine of the whatever.
Yeah, it
Cosine of the
equals
whatever.
sine over theta, if that helps. I don't know.
What, cosine?
Sine over theta?
What?
I'm not. No.
Are you saying this?
Yes.
Okay. Over cosecant of theta plus cosine squared of theta. Now, look and see if there's anything that would have a similarity of something I can cancel.
Well, the cosecant equals 1 over sine.
Okay, so I have sine over 1 over sine of theta. And still plus the cosine squared.
So then would it equal
Wait, you just
You-
sine
div-
squared?
Yep, divide by a fraction, multiply by the reciprocal. So, sine squared of theta plus cosine squared of theta is equal
Oh.
to.
Oh wait.
It's easy. It's easy. Don't look.
1.
1.
I forgot. Okay.
I'm not used to easy answers.
Not these days.
The answer is never 1 anymore. It's always like a random number.
It's just never.
It's never
I wanna
1.
go back to arithmetic.
Oh, really? Arithmetic.
Math was
6.
easy.
I thought he said I want to go back to orangutans, and I was like, that's the wrong class. That was Miss Marshall's class.
Nathan, math was easy till they added letters. That's all I'm saying.
There's more letters than numbers now.
I found some of my math homework from college that was no numbers a lot the other night.
No numbers.
Mm-hmm.
What?
Yeah.
Like-
I would burn.
Math homework with no numbers.
AX plus HB.
No.
I don't know.
Don't not even with like plus and minuses. Like
What?
these fancy symbols, I don't even know what they mean. Yeah.
I would burn that.
From the fraction where it's like sine of theta over 1 over sine of theta, how did you get the sine squared?
So if you divide by a fraction, you multiply by the reciprocal. So it ends up being sine of theta times sine of theta over 1, which just gives you sine squared.
I kind of like this. Not gonna lie.
18 is
Don't
cosine
make-
squared of
I
x.
mean,
I like this section.
False
I didn't say I'm gonna like the
security.
next section.
you like this part?
Yes, I like.
All right, cosine squared of x over cotangent squared of x.
Let's see
Um,
what we can.
Okay, let's
So
Well-
think about something you could rewrite.
First of all, you can rewrite the cotangent squared of
Oh, as 1 over
x
tangent?
as 1 plus tangent.
Or 1 plus,
Or
You want to, when you're thinking about how to rewrite it, you want to see what else you have in your problem. So what other thing do we have in our problem?
cosine.
Okay, cosine squared. So I would prefer cotangent to be rewritten in terms of something that has to deal with cosine.
Oh, so could we do the like?
Oh,
one-
cosine, cotangent equals cosine over sine?
Okay, and because it was squared, it's going to be cosine squared x over sine squared
I was
x.
making it way more complicated.
Okay, well, and sometimes I will tell you, sometimes these problems are purely trial and error. You're going to try something, you're going to plug in cotangent squared is equal to whatever it was that you said. I never remember them off the top of my head. I always have to solve them out. But it's like, you're going to tell me that. Then you're going to go through and you're going to be like, well, now I don't know what to do. You're going to erase it, cross it out, whatever, and you're going to start over with something different. You're going to try, and then maybe you're like, well, 1 over tangent, and then you're like, oh, that still didn't help me. And then you're going to get to your other option. That's why it's like the more problems you do with these, the better, which is why I do spend a couple days on this, because I would rather y'all get like really used to using these so that you don't get thrown off when you get to a quiz or a test and get stuck.
Okay.
So
Got the answer.
now what do I do with this?
Multiply by the reciprocal, so the cosines cancel out, so it'd be sine squared theta or x.
Doesn't matter. If you switch them all to thetas, it doesn't matter.
I got
Okay,
that
so we
wrong.
multiply by the reciprocal, making cosines cancel, and just leaving you a sine squared.
I did it, and then I wrote cosine squared over sine squared.
Now, some people get I don't know, they get excited, and they decide that they're gonna rewrite sine squared as 1 minus cosine squared. It's like, no, we want the simplest form. Leave it there. So just
I don't want that.
They like
when you get it to something that's simple, don't make it more complicated than it is.
Because then, if you try to do that too, you'll probably mess it up.
All right, 20.
I mean, you will.
picked up now.
Yeah.
All right, cosecant squared of x minus cotangent squared of x all over sine of negative x cotangent of x.
I know what
There's
that is.
literally no.
You know, Peyton?
No, I know what that is.
There's no numbers.
They're squared.
There's a.
I don't count those as numbers.
There's a minus sign.
That's not a number. That's a symbol.
Symbolizing CSE terms.
Symbolizing.
Okay,
Yeah.
so we could do cosecant. We could like rewrite that.
Do we have to
Wait,
do
can
something
we-
with the negative angle
No.
identity? The sign minus.
Yes, we will. So let's go ahead and do that part. So what happens to if you have sine of negative x? What does that become?
Negative sign.
Okay, so we are gonna do something to the top, but I'm gonna leave the top alone for the moment. We'll do the bottom first.
Sine and then x. Yeah,
Okay, negative sine x. Now, I'm gonna go ahead and just try to, again, I don't want you to have to write 18 million steps. If you can show all this in one step, that's fine. Okay, but what can I do to cotangent in regards to sine?
1 over. Wait, no, that's wrong. It's totally wrong. Cosine squared over. Sine.
Not squared.
Cosine
What are we
sine.
looking at? Oh, the cotangent.
Rewriting cotangent in terms of sine. So cosine x over sine x. Okay. Now, sines are going to cancel, leaving me on the bottom with negative cosine of x. Okay. Now, I'm not going to rewrite that yet. I'm going to wait. Now, any ideas what I'm going to do at the top?
you could leave it.
What Pythagorean identity, just read it off the paper as it is, includes both of those things?
Ooh. 1 plus cotangent squared theta equals cosecant squared theta.
Yeah.
How do you know? Oh, never mind.
Okay. I want to see if there's any that correlate to both. Now, I have cosecant and cotangent, okay, on the same side. So, I'm going to subtract cotangent over. So, 1 is equal to cosecant squared of theta minus cotangent squared of theta, which is now what?
1.
Okay, 1. I can rewrite the top as 1. So, then I have 1
Oh.
over minus cosine of x. Is that as simple as I can go?
No.
How should I rewrite that then? It might be a reverse of an identity you have written on your paper where you say something is equal to 1 over cosine. What's equal to
Oh,
1 over
secant.
cosine? Secant. Don't forget the negative sign, so it's minus secant of x.
That's
Oh.
fun.
How did I draw a box and it made a circle? Can we talk about that?
I've never
I thought it was
done
like
that.
I thought it was a 1, and I was like,
Yeah, I didn't know
What
what
just
was
why
happened?
is there a 1? I was a little confused.
Your box was just that bad.
Alright, so y'all know I don't normally do odd problems, and if I am going to do an odd problem, it probably means there's a reason. So I'm
Do you,
going
like check formulas like on the quiz test?
to, possibly.
Oh, whoa. The nod problem.
Whoa.
Whoa.
It's getting
That means you
serious.
should be a little concerned.
About to get wicked.
Cosine squared of x times tangent squared of negative x minus 1 over cosine squared of x.
Wait,
Take
is
a
that a
walk.
tangent?
Yeah.
Oh,
That's a 1 minus?
no. Wait,
I
what?
need some fresh air.
I need some
That's
oxygen.
Are you done?
the last one we're doing today.
Watch it. Wait, what if she did like that and then like over?
Over.
My brain needs to.
All over. No.
What? All over.
Right.
All over one.
Okay. Can we change tangent?
Can we cancel
to
out the
negative?
cosine already?
Can we change
Yeah,
tangent
can we
to
just, like,
negative tangent
Cancel
squared
the
of x?
cosine?
Yeah, can we just cancel the cosine?
Hold on.
Okay.
Okay. Deal with the negative first. Okay, like he's saying to do.
Yeah.
Okay, when you have tangent of negative x, you take the negative
tangent squared of
and
x.
throw it out front. So you're going to have, we'll do some of this all in one step here, okay? But the negative's going to be thrown out front.
I need to
Okay,
do that.
cosine squared of x times, how can I rewrite tangent?
Negative tangent squared of x. How do you rewrite
Yeah,
tangent?
like rewrite it in terms of sine or cosine.
Oh.
What is tangent?
Sine
Sine over cosine. Okay, I've already thrown the negative out front from
Oh, okay.
tangent.
Oh. So that's
Now,
like multiple steps.
Notice though, tangent was squared, so make sure you square both of those pieces. So it's sine squared over cosine squared.
I'd like to do it in like step by step so I don't get confused when I look back.
So we did multiple.
You're like,
That's
what
fine.
happened?
Yeah. Cause like
I'm not, that's the only thing I just was like, I'm gonna go ahead and just throw the negative out front and just, that's the only reason I did that in one step. But you can do it in as many steps as you want. Kill the trees, I don't care.
Wow.
Oh.
Wow. They're already dead. It don't matter.
What?
Well, mine's not, but.
Oh yeah.
Alright, so now what can I do?
You can cancel out the cosine on the top. Use the ones on the top, not like the one. Can you cancel out the bottom one too?
No.
Okay, then.
I cannot do anything with the one
Don't
on the
talk
very
about it.
bottom. I can do stuff with this one that I just put an
Forget
X
that I
through.
said that then.
So now, on top, I have minus sine squared of x, okay, because the negative is still there. It didn't disappear. Minus 1 over cosine squared of x.
So sine squared of x over cosine. Is that anything?
I can't do anything with that because there's two things on top.
Oh.
So we have to deal with
So
the
can we?
So do we have to change
What
cosine
can
in
we
terms of?
do?
No.
Can we like add one or something? I don't know.
Do you change the bottom to cosine negative or cosine squared negative x?
No, I can't do that.
I mean, sine. Is it something that we're gonna have to like reverse?
Yeah, that's the thing.
You multiply by the
Hold on, I'm verifying this one thing really quick. Oh, too far. Me.
I just need to let my brain like marinate in the juices of like this.
What?
Okay,
Never
in the
use
juices
that
of what?
analogy ever
Okay, in
again.
the juices of what?
Of this mess.
Okay.
I feel like it has something to do with the negative one.
Brain marinate
Make
juice
juice
should not be the same sentence.
So, technically, this negative sign is really out front
Hey.
Is that?
That's a mistake.
Stop.
Wait, where'd
Because
that negative
now-
sign come from? Wait, is that negative sign when you cancel the codes?
well,
So then we multiply.
because I've got this, okay?
Yeah.
If I want -1, sine squared minus 1 is equal to negative cosine squared.
So then on the top we could hit negative cosine squared.
Hold on a second. Hold on. I get rid of this. Like, yes, that's true, but hold on. There's an easier way to do this. By taking this out, okay, I can then flip. That's what I was trying to do. I can take this out and then I can flip this to be 1 minus sine squared of x because this negative was taken out front. And then I can put it on the bottom. So then the top is now cosine squared of x over negative cosine squared of x, which is equal to -1.
That was not pretty.
I don't think that was supposed
I don't like
to.
that.
Sure.
Wait, where did you get the cosine squared x over negative cosine squared
Because
x?
1 minus
1 minus sine squared is cosine squared from the identities.
Oh.
the
Because it's like-
Pythagorean.
And that's why you have to memorize.
Oh, because you like.
Yeah, like do
you
the
like
thing.
put it like.
You do the thing.
You have to switch the formula for it.
Yeah, you do the thing.
All right. And that's where we're stopping for today. We'll pick it back up